Here's my explanation of how to do this quiz. Cesium is a metal. Go look at your periodic table. It has a charge of 0 when it's on its own, and it is on its own. It is not combined with the oxygen yet. I would take notes anywhere you need to, hit pause, and write some stuff down. Not these examples, but relevant concepts. It's on its own. It's got a charge 0, and it's combining with oxygen. Look at the periodic table. At least the one I gave you has a star in it. That means it's diatomic. When it's on its own with its own kind, just oxygen, it is occurring in pairs. What can we do? We could put these together. Why? Because they're already apart and there's nothing else to do. There's nothing to trade around. Plus, it says synthesis, creating, putting together. So let's put them together. On your periodic table, cesium is a +1 when it's combined with other things, which is what I said we're going to do. Oxygen on your periodic table is a -2 when it's combining with other things. Remember, it's not diatomic because it's combining with something else, and this time it's not on its own with its own kind, so it's not diatomic. The charges have to add to 0, so we need a 2 there, and now they add to 0. Now we can balance it across the arrow. There are 2 oxygens going in, so there need to be 2 coming out. But that makes 2 sets of 2 cesium coming out, so there need to be 4 going in. Decomposition means it's going to fall apart. Basically, we're going to cook it real hard and we're going to make it fall apart. So iron is, they're telling me it's a +2 and it's with sulfate. Go look at your ion chart. It's SO4 -2. The charges need to add to 0, but they already do. Let's just leave that. And what are we going to do? Well, we're going to make it fall apart. You have some decomposition rules that I gave you. And for the things that contain sulfate, we said they create sulfur trioxide. You might want to write that down, but I think it's kind of obvious. Sulfur and trioxide. And oxide compounds, which means take oxygens and stick them on the other stuff. That would be the iron, wouldn't it? That's what we didn't use yet. And we know that this time iron is a +2. And we're combining it with oxygen, which we know likes to be a -2 when it's stuck to other things like the iron. The charges have to add to 0, but they already do, Mr. Swaney. You're right, so let's leave that. And then we can balance it left and right, but you know this one already is. Single replacement means that we're going to take these reactants, and then we're going to do a replacement. Well, of what? Well, let's write them in. Calcium is an alkali earth metal, and when it's on its own, it's a charge 0. You don't have to write 0, but I guess you could. And it's on its own because of the plus is between it and these others. Cobalt, we are told, is a +3 this time. And bromate, you can look up on your ion chart, and it turns out it's BrO3 -1. But the charges have to add to 0, so we need 3 of those. And what could happen? Well, calcium is a metal. It's even in a column that I labeled metals. And we know it likes to be +2 when it combines with other things. So all I can think of to do with the calcium is stick it on one of these. Well, it wants to be a +2, and that means it can't stick to a +3. It's going to stick to something that's negative, and there's only one choice. So let's stick it on there, and the calcium likes to be a +2. The bromate is a -1. That means we need 2 of those so that the charges will add to 0. And the cobalt kicks off and goes off on its own, and it is not +2 or anything. +3, I should say. It's not +3. It's not plus anything. When it's on its own, it will be a solid. It will be charged 0. You could write a 0 up there if you want to. And then we need to balance it left and right. The first thing I notice is that I've got 3 bromates on the left and 2 on the right. 2 and 3 can both turn into 6 so that they match left and right if I multiply here by a 2 and multiply here by a 3. If 3 calciums are coming out, I guess 3 went in. If 2 cobalts are going in, then 2 come out. Double replacement means we're going to have a pair and a pair makes a pair and a pair, and we will trade the partners like this. Lead is Pb. They're telling me it's +2. Thiocyanate is a weird one, but look on your ion chart. It's SCN -1. But the charges must add to 0, so there must have been 2 of those. Potassium likes to be a +1. Hydroxide on your ion chart likes to be a -1. The charges need to add to 0, but they already do, so let's leave that alone. Now, what could happen? Well, the pluses, for instance, could go grab a different minus. I mean, you could view it as the minuses grab a different plus. It doesn't matter. But most people think of it like this. The plus here is going to grab a different minus, and this plus is going to grab a different minus. So we will create lead 2 with OH minus, but the charges must add to 0, so that's a 2 there. And then K plus with SCN minus, and the charges already add to 0, so don't put a 2 here or there because the charges already add to 0. For all the kids who are shouting in their minds, but you didn't balance it, it doesn't make sense. There are 2 thiocyanates here and only 1 there. You're right. So that means I need to put a 2 there, though. Don't mess up the plus and minuses. Adding to 0, don't put a 2 here or there. Put a 2 in front. What did we just change? We just changed potassium. Also, there are 2 coming out, so there should be 2 going in. And you know what that did is it fixed the hydroxide. Now there are 2 hydroxides going in because there were 2 coming out. So that's good. Let's do 5. Aluminum likes to be a +3. Look at your periodic table. Carbonate on your ion chart is CO3 -2. The charges must add to 0. So let's make them be +6 and -6 by multiplying by 2. 2 positive 3s is +6. 3 minus 2s is -6. Plus nickel is a +2. And chlorate on your ion chart is -1. But the charges must add to 0, so we'll have to put a 2 there. Let's trade the partners. The aluminum could get a new negative, and the nickel could get a new negative. So we would get aluminum +3 with ClO3 -1, so we'll need 3 of those so that the charges add to 0. And then the nickel is a +2, and it will go with the +2 there. CO3 with a -2, they go together, and the charges need to add to 0, but they already do. And then we can balance it left and right. Let's see here. 2 aluminums go in, so 2 come out. That made 2 sets of 3 sets of chlorate, so that is 6 chlorates coming out. So that means I need a 3 here so that I have 3 sets of 2 sets. So that is 6 chlorates going in. Now I have 6 of these going in and 6 of these coming out. What else did we just change? Nickel, how many? 3. So there needs to be a 3 here. So there are 3 nickels coming out. And that just fixed my carbonate problem because now there are 3 carbonates coming out when there were 3 going in. So I fixed that by accident, which is good for me. Calcium is a +2. Hydroxide, we said on the back, is a -1. So there must have been 2 of those so that the charges add to 0. Carbonic acid, I told you what that is right there, is H2CO3. So what we have here is a special case of double replacement. The calcium will go with that, and the hydrogen will go with the hydroxide. So what you get, I would take a note with an acid-base pair like this, at least that we're working with so far, is you get water and a salt, a plus-minus pair of the other things. What are the other things? Is this with this, isn't it? Calcium +2 and CO3 -2. The charges already add to 0, so leave that. There's 1 calcium going in, 1 coming out, 1 carbonate going in, 1 coming out. But there are 2 and then another 2 hydrogens going in. That is 4 going in, so we need to have 2 sets of 2 hydrogens coming out, and there is your balanced equation.